Assalamualaikum warahmatullahi wabarakatuh.
We are going to present about
Application of Gauss-Jordan elimination.
My name is Nurul Izzati binti Abdul Ghani. My matrix number is 2024410424. And my name is Nur Ashira binti Ismail and my matrix ID is 2024407794. Our group descriptive title is Optimizing Cookie Ingredients Ratio Using Linear Algebra, and the title of our case study is Application of Gauss-Jordan Elimination Method in Ratio of Ingredient in Making Cookies.
The introduction to the case study. In baking, maintaining the correct ratio of ingredients is important to ensure consistent quality in cookies. When several ingredients are involved, adjusting recipes can become difficult without a systematic approach. Linear algebra helps solve this problem by modeling ingredients ratio as a system of linear equation. This case study applies the Gauss-Jordan elimination method to determine accurate ingredient ratios for cookies production.
Next is the purpose of the study. The purpose of this study is first to determine the correct ratio of ingredient used in making cookies. Second, to provide a systematic and repeatable approach for adjusting cookie recipes while maintaining consistent quality. And the last purpose of the study is to demonstrate the application of linear algebra techniques, specifically matrix method and the Gauss-Jordan elimination method in solving ingredient ratio problems.
Moving on to the methodology. Problem formulation. 3 ingredients such as flour, sugar and butter are used in making cookies. These ingredients are combined in fixed proportion to produce different batch of cookies. The relationship between the ingredient quantities are modeled as a system of linear equation. Then we will state the amount of flour used is X, the amount of sugar used is Y, and the amount of butter used is Z. And the equation is X plus Y plus Z equals to 20, 4X plus Y plus Z equals to 35, and X plus 2Y plus 5Z equals to 50.
Next is solution method. In the solution method, the system of linear equation is solved using matrix method, which is Ax equals to B, and the Gauss-Jordan elimination method, which include first, representing the system of equation in augmented matrix form. Second is applying elementary row operation, which is ERO, to transform the matrix into reduced row echelon form, which is RREF. And third is determining the value of X, Y, and Z, which represent the required ingredient ratios for cooking production.
Next, we move to the solution. Since we have the leading in the first column, so we don't need to change anything in row 1. Then we have to make the row 2 in the first column 0, so that the equation is row 2 minus 4 row 1 equals to row 2, and it becomes 0. And the whole row 2 will also change and become -3, -3, and -45. And the last row in column 1, we have to also make it 0, and the equation is row 3 minus row 1 equals to row 3, and the outcome is 0, 1, 4, and 30. For the second column, we have to make the row 2 is the leading, which is -3 to 1. So the equation is -1/3 times row 2 become row 2. And the answer is for row 2 in column 2 is 0, 1, 1, 15. For the row 1 and row 3 in the column 1, we have to make it 0 since there is not the leading. So the equation for the row 1 in column 2 is row 1 minus row 2 equals to row 1, and row 3 for the column 2 is row 3 minus row 2, and becomes row 3. The answer for row 1 and row 3 after we calculate just now is, for row 1 is 1005 and for row 3 is 003 and 15. Then we have to calculate the 3 in the row 3 and column 3, which is the leading, to become 1. And the calculation is 1/3 times row 3 equals to row 3. And the answer will be 0015. Last but not least, we have to make the row 2 in the column 3 0, which is 1 becomes to 0. And the equation is row 2 minus row 3 and becomes row 2. And the answer for the row 2 in the column 3, which is 0, 1, 0, 10. That's the result for the equation that we made just now. After performing Gauss-Jordan elimination, the solution obtained is x equals to 5, y equals to 10, and z equals to 5.
Next is discussion. Ingredient Y has the highest value, indicating it is used in the largest proportion in the cookie recipe. And ingredient X and Z have equal values, showing that they are required in the same ratio. The results ensure that the ingredient ratio are determined through quantitative analysis rather than estimation on trial and error. Applying linear algebra allows the recipe to be adjusted to scale to different batch size without changing the original ingredients proportion. Conclusion. This case study demonstrates that linear algebra provides a clear and systematic method for determining the correct ratio of ingredients in cookie production. By modeling ingredient relationship as a system of linear equations and solving them using the Gauss-Jordan elimination method, accurate ingredient ratios can be obtained efficiently. This methodology can be applied to other recipes of food preparation process that require consistent and precise measurement.
Thank you for watching.